And we're back at it again for day 3 of AP Stats Notes Online Edition. So remember, we're learning about Chapter 16 right now, which is dealing with a bunch of probability distributions. Yesterday, we looked over the geometric distribution, and specifically, I taught you guys how to use that on the calculators that I sent home with you. And then today, we're going to be shifting more into a binomial distribution, which I'll explain what that is. But before we do that, I do want to look at a question of the day together that is going to cover some of the stuff we did yesterday. So mainly, this is just to help clear up any misunderstandings you guys may have. So let's go ahead and jump right into looking at that. It's going to actually be in your textbook on page 431. We're going to look at number 16. So again, this is going to be a lot like some of your homework questions were. So hopefully we can clear up any of those questions you guys might still have. So as we are looking at this question, it says about 8% of males are colorblind. A researcher needs some colorblind subjects for an experiment and begins checking potential subjects. Now notice there is an A, B, C, and D for this question. This is not multiple choice. You do need to do all 4. So right now, if you could go ahead and pause the video and attempt doing this on your own. After you've done the best work you think you can, then go ahead and hit play and we'll go ahead and go through the answer together. All right, go ahead and hit that pause right now. All right, well, welcome back. I hope you guys all got the answer. Let's go ahead and start off by looking at A. It says, on average, how many men should the researcher expect to check to find one that is colorblind? So the key word that we're using here is definitely how many they would expect to check before they find one. So this is definitely an expected value question. I think that's kind of pretty obvious with the wording they use there. So remember, how do we go about finding the expected value of a question? We just, for a geometric distribution, which this one is because they're either colorblind or they're not, so we are fulfilling the Bernoulli's trials. And we said that for geometric, that's just 1 divided by your probability of success. That means that in this case, our success would be the 8% who are colorblind because they're trying to see how many they would have to check before they find one who is colorblind. So that means that we're going to simply go ahead and do 1 divided by 0.08, which obviously I know you guys are all doing that in your head, which gives you solid 12.5. Now, that 12.5, what does that actually mean? Remember, looking back at our question here, 12.5 means that we would expect if there was a line of men outside that were getting checked to be colorblind, we would expect to have to check 12 to 13 of them before we found one of them who was actually colorblind. Does that mean that it's always going to take exactly 12 or 13 people? No, that's just saying, like, on average, if we did this a whole bunch of times, we would expect somewhere between 12 to 13 people before we would find one that is colorblind. All right. So B says, what's the probability that she won't find any colorblind among the first 4 men she checks? All right, so let's break this question down. First off, it's asking for a probability, which is your hint that this is not an expected value question. Instead, we are probably looking at a probability question, which is pretty strongly hinted by the fact that it's probability in both B, C, and D. So, what are we finding the probability of? We're finding the probability that she won't find anyone who is colorblind in the first 4 men that she checks. So we are finding the probability that X is not going to be in the first 4 men. Now, this is kind of tricky how it's wording because it's saying that it's not going to be in the first 4 men. So we would say, what could be the first one that she is going to find? So if it's not in the first 4, what's the first one after the 4th person? It's going to be the 5th. So we are actually talking about X being 5 or any number above that. All right. So when we're going into the calculator, this may have initially seemed like it would be a 1 through 4, or it could have seemed like it was just going to be checking that the first one was the 4th guy, but it actually says she won't find any in the first 4. So we're going to have to look from 5 and up, which means we're going to have to jump to our calculator for a geometric CDF question. All right, so let's go ahead and shift gears over there. So remember, we get into this by going to our menu button, and then you go to 5 for probability, 5 for distributions. And in this case, remember, we said we want a geometric CDF. Now remember, why did we choose CDF instead of PDF? We chose CDF because this is a range of numbers. If it was asking for one exact X, we would go with the PDF. But because we have a range of them, we're going with the CDF. So we click on that. Remember, we said that our probability of success was the 0.08 for the color blindness of men. We said that we didn't want to look at the first ones 1, 2, 3, or 4. We want to start at 5 and check out all above that. Now, in this case, we don't have like an infinity button we can put in right here. So remember, just like we did with the normal PDF and CDF functions, we always make this the 99999 if we're trying to go up. Now, exactly how many nines? 4 to 5 should be fine. Just remember, it has to be large enough away from whatever the expected value is that the probability would be so small that it doesn't make a difference anymore. Okay, so we go ahead and hit OK there, and we can actually see that the answer to this question is going to be 72%. Now, obviously, it is 0.716393, but we can either round that to a 72%, or you guys could say that it's a 71.64%. Either way is fine, but that would be our answer to B. Now, just so that we don't have to keep flipping back and forth between screens, the next question, C, said, what's the probability that the first colorblind man found will be the 6th person checked? So if I want to check for the 6th person, that is when X is exactly 6. So we don't have to worry about a range of numbers. We can just go straight into our menu, 5 for probability, distributions, 5 again. And we're going to go down this time to geometric PDF, since we are looking at exactly one number, because we want to know the probability that the first colorblind person is the 6th one. So again, we'll put in our 0.08. We'll put our X value to be 6. We'll hit OK. And the answer to part C is going to be 0.052727. So in other words, there is a 5% chance that the first colorblind man would be the 6th person in that line. So moving right to the last one, D. D says, what's the probability that she finds someone who is colorblind before checking the 10th man? All right, so before checking the 10th man. So we want a success before the 10th one. That means it can't be the 10th one. It has to be one of the ones before that. So we're actually looking at a range again, and we're looking at a range from 1 to 9, because it could be any number before 10. We don't count 0 because in this case, 0 makes no sense. You can't have a first success on your 0th attempt. So we're going to go ahead and do 1 through 9. So again, that's menu. That's going to be probability 5, distributions 5 again. And we're going to this time go to geometric CDF because we need a range again. We'll do our 0.08, and we're going to go anywhere from 1 up until 9. All right, so we hit OK there, and our answer, it looks like it's going to be 0.527839, or 53%, or 52.78%, depending on how exact you want to be. So these are going to be the 3 answers for B, C, and D that you should have on your papers. You can check your work now to see how well you did compared to that. But at this time, we're going to go ahead and shift over to attempting our new material on binomial distributions. So now that we're shifting into our new binomial, what's the difference between a geometric and a binomial distribution? So remember, geometric was when we were just going to look, is it a success? Is it a fail? Those are our only 2 options, but we're going to keep doing it over and over and over until we get our first success. Once we got the first success, we stopped. Now, the difference is a binomial distribution means that we're still going to do those trials, the same Bernoulli trials, follow the same rules, and it's still either going to be a success or a fail. But instead of doing it over and over and over until we get our first success and then ending it there, this time we're going to define a set number of trials we're going to do. So this goes back to, like, if I asked a student to take 10 shots and we wanted to know the probability that they would make 3 of the basketball shots out of the 10. I gave a set number of trials, 10 trials. And then I was asking, what's the probability that you would make 3 of them? We could change that to say, what's the probability you would make 5 or more? What's the probability you would make 2 or less? But that's a binomial distribution, is when you have a set number of trials and you are going to try to figure out the probability that you will have a certain number of successes within that set number of trials. All right. So let's go ahead and see what the official textbook definition for this is right here. So textbook says the binomial model tells us the probability for a random variable that counts the number of successes in a fixed number of Bernoulli trials. Usually this definition isn't as great as one and we just make up our own, but in all honesty, this pretty much tells us exactly what we need to know. The binomial model, it is just a probability question type thing that counts the number of successes in a fixed number of trials. All right. So nothing too fancy there. We give a set number of trials and we're going to just see the probability that you'll get a certain number of successes. Now, the next thing says 2 parameters define the binomial model: n, the number of trials, and p, the probability of success. And we denote this as binom np. Now, don't let this get overwhelming. Remember, for the geometric model, the only variable we were dealing with was p, the probability of success. That has not gone away. But now that we have a set number of trials, there is a second variable to consider. So in this case, we are going to call these binom np. If you ever see it written in the textbook like this, that just means that you're dealing with a binomial problem and it has n number of trials and it has a p probability of success. So sometimes they'll write it like that to kind of shorthand it to move things along. All right, let's move along. This right here is the simple formula for doing binomial. All right, I get it. It's not exactly super simple looking, but don't freak out because remember, we're not actually going to be using this at all. Now, this C is talking about combinations. It's very similar to the permutations as well. But in this case, we don't need to use this because we already know that there's a binomial PDF and CDF button right above our geometric PDF and CDF button. So you can use this for notes, you can look at it if you would like, but in reality, what we really need to know is the application of this model. So we can jump right into looking at that. In your calculator, it is going to clearly ask for an n, a number of trials. It is going to ask for your probability of success, and it's going to ask for the number of successes we're looking at. Again, the PDF is going to be based on if that X, the number of successes we're looking for, is only one number, and the CDF is going to be when we're looking at a range of number. Now notice there is a formula down here at the bottom for mean and standard deviation. All right, don't let that scare you. In this case, the mean of a binomial distribution and the standard deviation of a binomial distribution is very similar to how we were looking at the expected value of a geometric distribution. For an expected value of a geometric distribution, we saw that, okay, if you have a line of people, how many would you expect to go through until your first success? For a binomial distribution, we have a set number of trials. So now what the mean or the expected number is going to be out of those set number of trials, how many do I expect to be a success? Okay. So if we go back to the formula here, that is the mean is equal to n times p. So all you need to do is take your number of trials, multiply it by the probability of success, and that will tell you how many you would expect to have. The standard deviation is the square root of n times p times q. So you'll plug that in your calculator, and remember that just means like, all right, we got our mean expected amount. On average, how far would we expect our answer to be away from that mean? So we're able to find both of those. Let's jump right into what a question is going to look like for this. We can see here it says, suppose 20 donors come to a blood drive. Recall that 6% of the people are universal donors. Remember, this was the one that was talking about O negative blood, all right? So it says, what are the mean and standard deviation of the number of universal donors among them? And 2, what is the probability that there are 2 or 3 universal donors, okay? So when we are looking at this, starting off with the first one, it says we need to find mean and standard deviation. So we're simply going to be using our two formulas. This is a binomial distribution because we have a set number of 20 donors. So because they gave us a set number of trials, we know this is no longer geometric, it is binomial. So the formula for mean for binomial was just n times p, and the formula for standard deviation was just the square root of n times p times q. Now, on the last slide, q was on there, but we didn't really talk about it. Remember, q is just your probability of failure. So in this case, n is our 20, p is 6%, and we'll write that as 0.06. And Q is the only one that's not mentioned up there, is just the opposite. So you would do 100% minus 6 gives you 94. So we would put 0.94 as that guy, all right? So when we're plugging these in, go ahead and multiply that out on your calculators, 20 times the 0.06, and that will give you about 1.2. And for a standard deviation, we would do the square root of our 20 times the 0.06 times the 0.94. And if you plug all that in correctly in the calculator, you should get 1.06207 in the calculator. So what does this mean? It means that if we had 20 people come in for the blood drive, all right, 20 donors, we would expect only like one of them to be an O negative, a universal donor, all right? And on average, that could go up or down by another one because that is our standard deviation. So we would expect anywhere from no donors to that would be universal donors up to about 2 donors that could be universal donors. All right. If you want to go within 95%, then we could go down to having 0 up to 3. But that is how we're going to knock out number 1. Now for number 2, we're actually going to switch into using your calculator again because it says what's the probability that there are 2 or 3 universal donors. Now there's 2 ways you could go about doing this. You could do a PDF for 2, you could do a PDF for 3, all right? Or you can do a CDF from the lower bound of 2 to the upper bound of 3. So let's go ahead and plug that in our calculator now. All right. All right, so we're going to go to menu. Just like before, we're going to menu 5, probability. We're going to 5 for distributions. And when we go down now, whereas we've been using the geometric PDF and CDF, we are now going to use binomial PDF and CDF. Now, I did tell you there's 2 ways to do this. You could either do binomial twice, and you could put in both numbers there, or you can go ahead and just do the binomial CDF and do them both at the same time. So let's go ahead and knock out the CDF and do them both at the same time. That seems a lot quicker for me. So that's how we're going to roll CDF. Now, what were our number of trials here? Remember, we had 20 donors. The probability of success was 6%. So remember, we always need to put that in as a decimal. And we said we want to know anywhere from 2 to 3 donors. So we go ahead and do 2 or 3, and we hit OK. Now notice it pops up. It says there's a 0.31058. So what does that mean? It means that there's a 31% chance that out of the 20 donors, we would find 2 or 3 that had O negative blood or were universal. All right. So really, it is that easy, guys. All right. So binomial, geometric, probability distributions in general, they're not super hard because we're going to do most of them on the calculator, which makes things a lot easier. So this is how we do the binomial questions. You would do the PDF the same way. You would just put in one X value instead of a range of them. If it's ever going all the way up to infinity, you do the same trick of the 99999. And so we can knock out any binomial or geometric question at this point. I'm not going to assign homework right this second because tomorrow I want you guys to use as a work day. I'm going to go ahead and post an assignment up on Schoology that you guys will be able to do and turn in. Remember, try to keep up with these so I can start getting those grades into the grade book for quarter 4, and we'll see where that puts you guys at. I know it is a little bit crazy right now as we're figuring all of this out, but please just keep faith, keep doing the work. We're going to just keep trucking it along. Tomorrow, Friday, will be the homework day, but also it's your last day technically before spring break. So I am not going to do videos all of next week. I will go ahead and shoot out some emails possibly tomorrow along with the homework. I will make some videos to shoot out because I want you guys to be fully informed of what it is going to look like moving forward. I have went ahead and learned how to use Zoom, which is kind of like a video conferencing application thing. And I'm going to start using that to set office hours so that if you guys have questions, comments, concerns, I'll set up like a specific time that I will be available on this video conference. I'll post it on Schoology with a link. All you'll have to do is during that hour or two, you'll just have to click on there and you'll pop in with me. You can either do video, audio, or you can just type it in, but you can ask me any questions you have. We can have discussions. I'll give you a chance to talk with other people in your class. So start looking for those. We probably will pick those up as soon as spring break is ending, but I'll give you a bunch of information on that tomorrow. Again, thanks for tuning in, guys. I really hope you guys are staying fit, staying clean, and staying healthy. You guys have a great day. Bye.